Hi, how are you? This is Sung and I'm the Principal and Director of Sky Academy, and in this episode, this is what I promised to all the conscientious students out there who really want to understand why the perpendicular distance formula works. And the perpendicular distance formula is the distance from a point to a line is going to be the absolute value of A, x1 plus b, y1 plus c in absolute value, all over the square root of a squared plus b squared, right? And there's a number of ways of showing why that is the case. Have a think about one way, but the way that I'm going to show you, there's a way that you do know how to do it, but I'm not going to do it that way. Have a think about what that might be. And I'm going to show you another way which is a little bit more elegant, and not only is it a little bit more elegant, but it'll also involve some some trigonometry, okay? So this will be interesting for you guys, and at the end I'll tell you the other way that I would have done it, okay? So let's have a look and launch into it. Just say you've got a straight line, and that straight line had the formula ax plus by plus c equals to 0. You have a point which is x1 and y1, and what we want to do is we want to work out the distance, okay, between P1, or the shortest perpendicular distance, which will be here. Let's call that the distance, and let's call that point here, let's call that point Q, right? Here's what we do first. What we do first is we draw, we extend a line horizontally or parallel to the x-axis all the way to the line, okay? Now, the y-coordinate of this line is y1. Do you see that? The x-coordinate of this line, or the coordinates of this line, will be y1 as well, because it's at the same height, because this is y1, alright? But let's work out the x-coordinate. The x-coordinate is found by simply substituting y1 into this equation, yes? So you've got, and let's call this line, let's call this point R. So the coordinates of R, are, alright, A found by A, x plus b, y1 plus c equals to 0, and then we just want to make x a subject to the formula, so ax is equal to minus b y1 minus c, so x is equal to minus b y1 plus c all over a. Does that make sense? And the reason why this is plus here, because this minus is distributive over the by1 and the c. Okay? So x is equal to, the x-coordinate is equal to minus by1 plus c all over a. Okay? Does that make sense? Alright. So, what would that make this distance here? The distance here, right, distance PR, would be equal to basically this coordinate minus this coordinate, okay? Or sorry, this coordinate minus this coordinate. Yes, it'll be that distance there, right? So basically what you've got is your, what is it? x1 minus by1 plus c over a, right? And it'd be the absolute value of that. Yes? So let's work that out. It would be ax1 over a plus by1 plus c all over a, which would be a x1 plus b y1 plus c all over a, and it's the absolute value of that. Does that make sense? So the distance there would be a x1 plus b y1 plus c all over a, and it's the absolute value of that. Now assuming a is a positive number because it is expressed in general form. Okay, so a needs to be positive if it's in general form. Okay, so that's that distance there. Now the other thing that I want to do is talk about this angle here. That angle there is theta, right? Not only is that angle there theta, but if that angle there is theta, that angle there will also be theta, because you've got alternate angles on parallel lines. Does that make sense? Good. Now this angle here is the tan of that angle there will be equal to the gradient of the straight line. Okay? Does that make sense? Alright, and this is where trigonometry comes into it. So if you don't understand that, you can go back and look at the trigonometry section and or the video where I talk about gradient, and you'll see that the tan of this angle, right, will also be equal to the gradient. So the gradient of the line is a x plus b y plus c equals to 0, and I'll come around this way so that you can have a look. Now I would make y the subject of the formula, so by is equal to minus ax minus c, y is equal to minus minus a on b, x minus c on b. Alright, so m is equal to minus a on b. So tan theta is equal to minus a on b. Good. Now if we know this line, PR, we also know that we can get PQ by trigonometry. Yes? So if I'll work over here, so PQ, which is the distance that we want, is going to be PR and its opposite over hypotenuse, right? Which is sine of theta. Got that? Now, if the tan of theta is a minus a on b, all right, if we draw a right angle triangle where that's the adjacent side over the opposite side over the adjacent side, a on b, the other side would be the square root of a squared plus b squared. Does that make sense? Yep. So in other words, PQ is going to be PR times sine theta, alright, A on square root of a squared plus b squared. Okay? Does that make sense? Now all of that is equal to PR, which is equal to that, the absolute value of ax1 plus by1 plus c, absolute value, all over a times a, all over the square root of a squared plus b squared. Now, remember how this is all absolute value? Yep. Distance has to be positive, so we're going to keep the absolute value. Even though there's a negative there, we know that everything here has to be positive, right? So if we work that out, what we have is a x1 plus b y1 plus c, absolute value. The two a's cancel out, and on the bottom we have the square root of a squared plus b squared. Okay, so that is how we prove that this is that this distance is equal to this formula. So now that we've worked out the distance, the perpendicular distance using this method, let me go through the other method with you, okay? The other method, if you've been thinking about it and curiosity is killing you and you'd like to know, is doing it this way. I won't go through it. You can actually have a go at doing it. But basically, if you've got point P, what you can do, and you know that this line has a specific gradient, you'll know that this line, which is perpendicular to it, will have a gradient that is perpendicular to this line. Okay. As a result, you can work out the gradient of this line. You know a point that it passes through. So using the point gradient formula, you can work out the equation of PQ. Once you've worked out the equation of PQ, you can work out the point of intersection between this line and this line. Okay, so the equation of PQ and the equation of QR. Right? And you can work out the point of intersection. Once you've worked out the point of intersection, you can find the perpendicular distance by using the distance formula. Okay, the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 all squared. Okay, so they're the two ways that you can work it out. I find this way to be quite an elegant way of doing it. It will require a little bit of trigonometry and outside knowledge, but it's not beyond you to be able to work it out. Okay, and it really does prep us how to use the information that we cumulatively learn from various units of work. So thank you very much for watching.